Hiya! So in this video, we're going to talk about something called the most probable outcome. So what we're going to do is, so when you recall from our last example, remember how we had all these numbers, right? So we had, this was the probability of getting 0 fours, this was the probability of getting 1 4, probability of getting 2 fours, 3, 4, 5, etc. And then 6 and 7. And 7 was scrunched up in the corner. Sorry about that horrible writing. So we had the distribution, right? And if you notice, P of 1 kind of had the highest chance of appearing. And so what this means is that the number 4 in that previous example had the highest chance of appearing one time. That the number 4 has the highest probability of appearing exactly one time. So what we want to do is we want to generalize this. Like what's going to be the most probable number of times something exists? So if I have n independent trials and each trial has a probability P of being successful, then what might we expect, right? The kind of layman's idea here is, well, just take the average, which is just n times P. So as a quick example, if I flip a coin 4 times, right, then I expect 4 head, right? I flip it 4 times. Each time I have a 1/2 chance of getting tails. I expect 2 heads, right? So this logically kind of makes sense on this average. Now this is close because the thing is, you have to remember that sometimes we're stuck on integers, right? So we can't always get something a little like a decimal, and we'll see this in examples in a little bit. But so we have to kind of differentiate between our expected value and what's called the mode, which is the number that is most likely to occur. So if we let m be the trial that which the highest probability, so we let m be the highest chance of anything else. In other words, we let the following thing happen. We let P of m be greater than P of k for everything. For all k, then we call this the mode. This m is the mode. So it's the item with the highest probability. So in our case from above, 1 was the mode. It's the highest number of 4s, or the number of 4s that will appear with highest probability. And that gives us, so now the question becomes, well, how do we calculate this? We know it has to be around n times p because that's the average. Right? It makes sense it would be near the average, but what is it exactly? And it turns out it's really close to the average, but off by a little, because we need to look at integer numbers, right? So it turns out the mode, m, is given by the floor of np plus p. So we have to add a little correction factor here. Now, what is this floor function if you haven't seen it? It basically removes the decimal part. So if I take 2.6371, the floor basically says, yo, all of you, fudge off, we're done. We don't want to deal with you. We don't care about the decimal. So we just get 2. So it basically just keeps the integer part and it forgets about the remainder. Now the next something that's similar, right, is the what's called the average, right? The thing that we've been talking about, the average value, what we expect to kind of happen. And this is what's called the expected value. And this is where terminology is slightly confusing, because you would think the mode would be the expected value, right? As in, like, that's what we would expect. We would expect the number 1 to appear the most. But in reality, the expected value in this case is slightly different. The expected value is actually just what value we would expect if we forget that we actually want integers. And in this case, this is just going to be the average we were talking about. So it's defined to be this average. So it's NP. And a lot of times we'll see this as, we'll denote this by mu for the binomial coefficient. So yeah, so we have this mu for the binomial coefficient. And yeah, so it's a little confusing, the kind of two. The book uses the term mean to mean the expected value. But note that we will always use expected value because if not, it'll get confusing later on. So the way to kind of think about this, and we'll actually, let me look at two different examples of where this differentiation comes in, and we'll look at that in the next video. But know that mode and mean or expected value are not the same. So mode, which is expected highest probability outcome, is not equal is not equal to the expected value usually. So we'll look at those examples in the next video.